This is what you can expect during the session. What is Singularity? We're going to be introducing Singularity, go through the architecture, discuss some unique features that make it suitable for onboarding large data sets, because that is Singularity's strongest. And then look at deal execution and management, data retrievals, and what we are doing, the improvements, or what we are working on Singularity between now and April, between now and November. And for some reason, my slides are, there we go. All right. So Singularity is an open source tool for onboarding large data sets to Filecoin, like I just mentioned. And it's an open, it's an all-in-one platform where you can do data preparation, deal execution and management, and data retrievals. So I think as of today, most of the large data files onboarded to Filecoin were prepared and the deals were created using Singularity. And you can appreciate some of these statistics. More information is available on the website, and feel free to scan the QR code. So in terms of the architecture, there are a few important components I just want to talk about that make Singularity work the way it does. And the first one is its ability to support connection, leverages Aeroplane, and then supports connection of more than 40 storage or data sources. And this range from S3, Google Drive, Dropbox, your local file systems, if you have mounts, anything that, any source or any platform where your data is, you can easily connect it to Singularity, and then you can start the data preparation and uploading to Filecoin. So the next important thing is the preparation worker, and this is just the workers that are responsible for generating metadata. So one of the most important features we're going to talk about is the inline preparation approach. And Singularity does support two ways of preparing data and uploading the same data to Filecoin. One is just the standard, you have raw files and then you generate car files and you serve those car files to an SP when you're creating deals. And then the other one, which is more suited for large data sets, is the inline preparation. And here you simply generate mappings of the raw files to the car files, save these as metadata in a database. And then when you're creating deal schedules, you serve this metadata to the SP. The SP pulls this deterministic logic, understanding how to generate car files. And then they generate car files on their end upon streaming the raw files. So, and as we shall see shortly, you save disk space. They need to have double disk space to hold the car file and to hold the raw files before you can upload them to Filecoin. We've mentioned the deal engine, and this just allows you to schedule deals. Content provider, this is the component that routes requests from users and also routes requests or data to SPs. It helps users serve raw files and even car files to SP. And then the deal tracker tracks deal execution, event and state changes, and exposes on-chain events and states to users. I've mentioned the I've mentioned inline preparation. And like I said, it's simply you're mapping and you're deriving representation of the understanding of the raw files, their directories. You start by streaming these raw files through the Singularity's preparation workers. They're chunked. And once they're chunked, metadata is generated. That is saved in a database. And then you solve this, like I explained, while scheduling deals, you send this metadata to SPs. So what is important with this approach or technique of data preparation is for large data files where you have, let's say, a petabyte or 2 petabytes, for instance, and you want to upload them to Filecoin. If you were to require double disk space very quickly, if you have large files, it becomes expensive and it becomes inefficient. And so you want an approach and you want a technique where you can simply just maybe incur an overhead of about 1% to save the metadata and the understanding, and then schedule deals, point the metadata and the mapping between your raw files and the car files to an SP, let the SP stream that as well, and then generate car files automatically upon the raw files landing on the environment. So you get to save on time, you get to save on space, and obviously because you have this information in the database, also you can do reverse mapping. You could request raw files, and if you have the metadata, you can request raw files from car files. So sometimes users will delete the original files after they have uploaded them to Filecoin. And if you want to retrieve original files, so you just want to retrieve files in the original form, leveraging this metadata and an unsealed copy, you can retrieve original files. And so I've mentioned less storage is needed, and that's exactly what happens. You have the SP streaming directly the files directly from their source. And obviously, you will be leveraging the metadata API, like I mentioned. So it's the metadata API that the SP uses to pull the metadata from the user's database, the Singularity instance a user has installed, and then using that metadata and with the deal parameters, stream the raw files, generate car files, seal them, and then be able to submit proofs. So in addition to the metadata API, which is the most important one for inline preparation, Singularity does support a one-to-one mapping between its CLI handlers and all the API routes. And you can take a look at all this information from the website and from the documentation. So I did mention it supports or it enables users to schedule deals with Filecoin storage providers, and push mode is supported. You could do a one-off if you don't have a lot of data. And if you are uploading, let's say for conversation's sake, 100 terabytes or even 1 petabyte, you could come up with a pattern. You could come up with a schedule of frequency, and then you bake in all these while you're creating the deal schedules, and then your files will just upload and the deals will get executed. You can also limit how many deals like in flight, even before, let's say, depending on the sealing pipeline or the capacity of the SP, you can actually determine before the deals get sealed, how many deals should be proposed at any given time or point. Should the SP just be able to seal, for conversation's sake, 30 deals every hour? You can determine all these things. And some of the enhancements we're working on will make this even easier in such a way that users will be able to just define templates, deal scheduling templates, and then you just select the template and while you're creating your deals. The next important thing that Singularity does support is retrievals of data, and you could be retrieving these from an unsealed copy that ESP has. You could also just be retrieving this directly, of course, from the ESP, but if you're leveraging LASI, going through the API, all these are ways that, provided the ESP supports a retrieval protocol, HTTP, GraphSync, and the rest, Singularity does support that. And you can retrieve different versions of a file, a whole directory or data sets, snapshots, all that. So one other interesting thing and advantage of the metadata generation, and of course the API, is once you have that understanding and the mapping between the car files and the raw files, you can actually be able to retrieve a specific piece, very small piece, and you're necessarily going to have to retrieve the whole data set before you can access the piece that you want. And now, between now and November, we are working on some enhancements. Singularity is getting a bit of a makeover. We have some backend enhancements, and we will have a new UI, UX. So everything that Singularity does support right now in the next 5 weeks, there will be the first release of this UI UX, at least for testing. This is going to be predominantly by folks using Singularity currently, those who are comfortable with it, used it before. You're welcome to download that UI, try it out, and give me feedback. In the next 12 to 16 weeks, there will be a better version of the same UI with more of the backend enhancements I'm going to be talking about shortly. Also released to a wider public or a wider audience. And yes, we'll be announcing this, communicating this. Again, we expect feedback. We're imploring you guys to test and give us feedback. So some of the things that we're going to do on the backend side, the enhancements around how we are managing the wallet address. So there's something very important. Something very important here under this slide. I didn't spend some time talking about trustless invariance here, the guarantees. So right now, the support of this capability that you can import your Filecoin wallet address and its private keys and manage it within Singularity, very useful. So you can be able to sign off these transactions. And of course, as a user, you will be in control of the generation of the DAG, the representation or the understanding of the Filecoin, the data, the files directory structure, and the compy, which is eventually the PCID that you pass on to the SP as part of the deal schedule. So why is this important? This is important because in a decentralized space, tools, you should have these guarantees. Without these two guarantees, without the guarantee that the data you handed over is what eventually gets sealed, so the DAG gen and the compute calculation, without you signing off transactions, then you're just back to Web2 offerings like S3. All right, so under the wallet management enhancement, the module, we're going to bring in the capability to create a new Filecoin wallet address. So currently, users have to set up lotus. You have to sometimes wait for it to sync before you create a wallet address, initialize that wallet address, then come and import it in Singularity. It's just too complicated. It complicates the user flow unnecessarily. And this is something we can easily have an easy integration. Again, if you want to manage the wallet address, you have to depend and use Lotus to do that. That means you need to have at least two systems, maintain two systems before you can do anything on Singularity. We want to reduce that distance and just make it easier for users to even see their wallet address balances, and this is both Fill and Fill Plus. And then visibility to Filecoin proofs directly on Singularity from the same pane. This is something we're interested in doing. And it's both POREP and POST. POST is most important. I mean, both of them are important, but POST is a recurring one. So there's going to be capability for users to see that directly. And you don't need to go through another explorer before you have the guarantee and the comfort that the data you uploaded on Filecoin continues to be preserved. And then a bit of enhancement on the inline preparation. So right now with Curio being rolled out and a lot of SPs adopting it, and there is a field also that is responsible for padding, or rather controls how much padding you can do to pieces, especially verified deals. We're going to make sure that all pieces generated by Singularity, the padding stops at the next ceiling, and we don't end up with highly padded pieces that SPs will have a basis to reject. We're also going to extend this passing. Right now, that limitation is just to DAG pieces, but we're extending this capability also to pieces containing data. Metadata management. So to support search, discovery, like use of all this data that has been uploaded to Filecoin, users want to use human language to search for this information to determine what they can be able to download or not, and how they can use this data. And so we want to make it easier because most of these data sets already have metadata collected. We want to make it easier for users to use that, leverage that, be able to see that, actually see the metadata first before you determine or you decide whether you want to download the data or not. And currently, one just requires a CID. CIDs are not very user-friendly, so we want to bring in something that is user-friendly. And then at the moment, a lot of important logging and errors isn't handled properly with Singularity. So sometimes you'll have pieces failing and you have to go through some screens, some logs that not even packaged properly, not presented in a friendly manner. We want to make sure, first of all, every important error during preparation, during deal scheduling, as SPs are sealing this data, anything that happens is logged properly, either in a table somewhere or file somewhere, and then these eventually needs to be exposed to users through the UI, UX. It just needs to be able to determine, hey, I started this preparation, it fails, a few pieces failed here and there for whatever reason, either the source of the data changed, whatever other reason, I need everything to be logged somewhere and to just be easy to find. Using a PCID or even the piece, the preparation name, somebody should be able to identify what went wrong and be able to resolve it. And then very importantly, we want to optimize the user flow. Currently, a user would have to go through around 16 to 20 steps to complete just a single upload process. We want to cut that down, reduce that even to 5, at most 6. By the time we bring in integration and enable users to obtain fill and fill plus directly, we should be heading toward 3 to 4 steps at most. So, and part of that will bring in scalability in the sense that we, if possible, let's keep certain things and automate them. So a user doesn't have to like manually create a preparation. By virtue of you pointing Singularity to the source of your data, preparations should be created automatically. And that process should be very simple. So just during that screen, you should specify deal parameters. And once that is clear, you should just click one button and your data deal schedules should also be created automatically. Your data should be uploaded to Filecoin. And if there are errors either during preparation or the deal scheduling, again, to my point earlier, they should be logged and it should be clear and easy for users to access. And then we've realized there's so many on-chain events, especially as these pieces get sealed by SPs, and even post that as they're submitting proofs, we realize a lot of these things are not logged nicely. There's like no schema for like archiving all this, committing all these information, all these events and state changes to the local database. So we want to extend the database and have something like an events table where if something has happened on the SP to the piece, even post sealing, we want all those important events logged there and make it easier for users to see. And finally, enhancements in private key security. Right now, private keys saved in the same database as the rest of the application data. Not very secure, not very smart design. So we want to explore how we can increase privacy there, either encrypt if we still must keep it within the database, or look at other ways to secure private keys. And with that, please look out for announcements from us once the UI UX is ready for testing. You can reach me through Slack or my email, jefferson@phil.org. Thank you so much for your time.